All right, let's start off on number 1 here. We want to find the inverse function. So anytime we're talking about inverse, we should always be switching x and y as kind of our first step here. So I'm going to switch this to y minus 1 over y minus 3. And I'm going to switch the y into x. Now we need to isolate y. Now we do have two y's here. So what I'm going to do is I'm first going to multiply this over. I'm going to distribute that x. So we get xy minus 3x equals y minus x. Nope, not y minus x, y minus 1. All right, and then I want to get everything with a y on one side and everything without a y on the other side. And so we would write this then as xy minus y equals 3x minus 1. Next up, we would GCF here a y, leave me with x minus 1. And then we would divide both sides by x minus 1. And that would give us our answer. F inverse of x equals 3x minus 1 over x minus 1. Now, the problem with this is that I see that answer is not really there. But the good news, anytime we have a fraction, we can always multiply the top and the bottom of that fraction by -1 and get another equivalent answer. And so this would actually be an equivalent answer right here if all the signs were switched. And so I see that answer is actually there, and it's written in a bit of a different order than that, but I would definitely say it's option A, 1 minus 3x over 1 minus x. All right, next up here we got number 2. So this is a composite function. Whenever they write it with that weird dot, it really means g of f of x. The other thing I notice here is it says which of the following are equivalent, so it doesn't necessarily need to be the final answer. It could be any of the steps along the way. So I want to start off here with a g of, and then I always like to plug in my f function there, which is x plus 3. And so this will be, if I go to the g function and replace those x's with x plus 3, that'll look like that. Okay, and so right off the bat, I actually see that option F is correct because that is that first step there of actually plugging it in. And then it looks like the other ones are kind of simplified here, so I'm going to go ahead and write this twice and FOIL it, of course. Give me x squared plus 6x plus 9. And then I'll go ahead and distribute this, 3x minus 9 right there. We'll combine like terms, give me x squared plus 3x, and then the 9's actually cancel. And so then I see that this option is correct. And then my last step would just be to, I would say that option C is correct because we just GCF an x. And that's all I see there. All right, number 3 here is really asking me kind of everything about this quadratic. So I'm going to go ahead and find the vertex first. So we get x equals negative b over 2a. So that's 6 over 6, so that's 1. Plug that back in, find the y value. So we get 3 minus 6 minus 24. I would just do 3 minus 30 is negative 27. So I know my vertex is 1 comma negative 27. So that vertex here looks correct. And then the vertex form, did they switch the sign here? Yes. And then keep the y value the same. And then they also grabbed the 3a value from the original, so that one's correct as well. And then if I kind of visualize this, it's an upward-facing parabola, so it's going to go like this. And then so I would say that the min value is negative 27. That is correct. It's the bottom of the graph is the vertex, not the top. So now I need to find intercepts here. The y-intercept is in standard form always c, so I know that one's negative 24. So now the x-intercepts, I'm going to go ahead and plug in 0 for y. And then I'll go ahead and GCF a 3. That'll be 8, okay. And then we'll factor it some more, x minus 4, x plus 2. So then x equals 4, x equals negative 2. And so obviously negative 4 is not correct, but negative 2 is. All right, so the next step here for this function, which one is f of x squared? So what I need to do is take 4x plus 12 and then square it. So I already see A is correct. Now, a lot of people actually think that E is correct, but this one is not correct because if you are going to GCF a 4, The way you should really think about it is I GCF the 4, but it is still all squared. And then so for that reason, I would say that D is kind of the correct way to do that, and E is the incorrect way to do that. So even when I GCF the 4, it still needs to be squared, which means that if I really want to take the 4 out, then I can just send the squared right there and there, since those are multiplying, and write it like this. That is okay. Next up then, they do have some that are kind of simplified form here. So what you can also do is write 4x plus 12 twice. And then go ahead and FOIL it, so I get 16x squared. Let's see, 48x and 48x is 96x, and then plus 144. So then I can kind of see that C is incorrect, and also B, because if I do see I can GCF a 16 here, but I see that what would be left over is 3 terms. It would be x squared plus whatever 96 divided by 16 is. That would be 6x plus 9. And then I could write it then as 16 times x plus 3 squared, which is really what I had over there. So that would say that A, D, and F are the only ones that are correct. All right, number 5 here, I know that the parent function here, this looks like a half parabola on its side, and so that is a square root function or a radical function. Okay, and then I know that the square root function either begins or ends at a point right here, so the point here is 3, 3. So then I would say that the domain here is negative infinity to positive 3 with a bracket, because that point is actually there. All right, next up, number 6 says a new candle is 8 inches tall, burns at a rate of 2 inches per hour. What's the height after T hours? So this one is just a little mx plus b here. We're starting off with 8, so that's your b value, but it's actually decreasing in height, so I would say negative 2t. Number 7a, I always start with the inside, so then that would be g of 1, and so g of 1 would be 5 minus 1 squared, so that would be 4. So then I have to take that and plug it into the outer function, so f of 4 then would be 2 times 4 minus 6, and so that would be 2. So I'll let you guys try part B there. For part C, I would think of this as g of 2x minus 6, which means I need to plug that into the g function. Now, very important on this one, we don't want to distribute the negative yet. Because of PEMDAS, we really need to square this first, and then we're going to distribute the negative. So that would be 4x squared minus 12x is minus 24x plus 36. And then, so now we'll distribute the negative. And so, I don't want to rewrite that, so I'm just going to distribute it like this with my blue. And then combine like terms, giving us negative 4x squared plus 24x minus 31. All right, next up, number 8. They're asking if this is a function. Honestly, what I would be looking for here is, do we look at all the x values, and do we have any repeated x values that go to different y values? And I actually see no. And so I'm going to say yes, it is a function, and we have no repeated x values. You can kind of visualize that if we did have something like, if we had 3, 5 right there, and then we had, let's say we had 3, negative 2 right there, you could see that that would fail the vertical line test. And so since we don't really have that, then that's why this is a function. All right, next up, number 9, we want to maximize the area here. So what I'm going to do is I'm going to label this side x and that side y. So I know the area is x times y. However, I know that we have 120 feet of fence. And so for my fence, how many y's do I need? Well, it looks like I need 2 y's, and then it looks like I need actually 4 x's, because even though there's 3 pens, we would need four fences to split them up like that. So what I'm going to do then is I'm going to isolate either one of these variables. I'll go ahead and isolate y. So 120 minus 4x equals 2y. And so y equals 60 minus 2x. So then I'll substitute that in right there. So that would be x times 60 minus 2x. And we get negative 2x squared plus 60x. And so now we'll go ahead and maximize this, which is find the vertex. So that would be x equals negative b over 2a. And so then we got negative 60 over negative 4, which is 15. And now that would be what I need to make x in order to maximize it, but it did just ask for the max area, so I'm going to actually plug that back in to my area function here. So negative 2 times 15 squared plus 60 times 15. Definitely a calculator question here. And so I would get negative 2 times 15 squared plus 60 times 15. And that would be 450 square feet is my max area that I can fence. All right, next up here we have this function. They call it capital F, and they're saying it got created by composing two functions, f of g of x, in that order. And so what are two possible functions for f and g? There are multiple correct answers for this, but I would say that the most logical way to think about it would be that the inside here would be g of x as x minus 10, and then the outside is really the fifth power, so I'd say f of x equals x to the fifth power. So if I did plug that g into f, that would create that final answer. So this is kind of like asking for the question. All right, here we have a piecewise graph, and it says that Sarah made $25,000 last year, but had $5,000 in eligible deductions. And so what deductions kind of mean is that you actually get to subtract those out before you plug it in. So if you want to think of it like t of 25,000 minus 5,000, so that'd be t of 20,000. And so then that would go into this middle function because of that or equal to right there. So it would be 0.09 times 20,000. Use a calculator for that. And so that's going to come out to $1,800 in tax owed. All right, next up here, number 12, it gives us two functions, as for f of g of x. So we got f of, and then I'm going to replace that with rad 2 minus x. And so then I plug that in, and it's rad 2 minus x squared plus 1. And so that's 2 minus x plus 1 because a squared and a square root undo each other. So then I would just say this is negative x plus 3. Now, the domain is a little bit more complicated here because when I'm looking at restrictions, domain restrictions, I need to take into account the final answer, but also the inner function. Now, for the final answer, I would say that there are no restrictions because there's no radicals nor denominators. However, my inner function here, I know that it has a square root, so the inside of the square root needs to be greater than or equal to 0. So I'm going to go ahead and solve this. So negative x greater than or equal to negative 2, and then x is actually less than or equal to 2. Now it asks for interval notation, so I'd say that's negative infinity to 2 bracket. All right, this one asks for the average rate of change on the graph from negative 7 to positive 10. So that is actually this point right there and that point right there. So I would just, you can actually just count the rise over run if you want. Or you can really show your work here if you have the 2 points. So I would say that one is negative 7, 4, and then we have 10, negative 4. And so I'm going to kind of ignore all the points along the way. I'm just going to do y2 minus y1 over x2 minus x1. And so that's negative 8 over 17. And there we go. This actually makes a lot of sense to me that this is negative, because if we actually connected those two dots, it would create a negative slope. All right, next one gives us an equation here. I see it is a negative quadratic, so I know the parabola is kind of looking like that. It asks how many units should be produced, should be manufactured to obtain the maximum revenue. So I know it's talking about the vertex, but it's actually not asking what the maximum revenue is. It's asking how many units. And units is really x, so all they're looking for is the x value of the vertex. So I'm just going to do x equals negative b over 2a. I got to be careful here because they did kind of switch these around. This is still a because it's attached to x squared, even though it's written second. So this will be negative 192 over 2 times negative 0.4. So it's negative 192 over negative 0.8. And that is actually 240. All right, next up here, I got g of f of x. So I'm going to do g of 1 minus x squared. And that is going to be, let's see, 1 over 1 minus x squared. And I would just say that's Oops, that's fine for our answer there. Now it's domain, so we have to look at the restrictions of the inner function and the final answer, right? So the inner function, 1n minus x squared, actually has no domain restrictions. However, the final answer, 1 minus x squared, cannot equal 0. So then I would say I would factor this. You could also solve this one with square roots, but I would factor it. We don't need test points on the not equals to, so I'm just going to say x cannot equal 1, x cannot equal negative 1. So then my domain would be negative infinity to negative 1, union, negative 1 to 1, union, and then 1 to infinity, just excluding those two numbers. Notice that we are including 0 here, even though it was 0 is restricted in the outer function. We do not take that into consideration when talking about composites. All right, next up, number 16 asks for the minimum or maximum value. So either way, that's always talking about the vertex, and it's actually also talking about the y value. So I got to find that. So I could say x equals negative b over 2a. That's negative 1/2, and so y equals negative 1/2 squared plus negative 1/2 plus 2. So I need to square that first. That's going to be 1 over 4. And I'm going to go ahead and build a common denominator right now. So I'm going to make that 2 over 4, and I'm going to make that 8 over 4. And then so this will be 7 over 4. And so next thing I need to decide, is it a min or a max? That's really based on the a value. So since that's positive, I know that this is a upward facing parabola. It probably looks something like that. And so obviously its vertex here is at the minimum. So min value is 7 over 4. All right, next up here, they want us to do the domain of g of f of x. So that's going to be g of x squared. And so that's going to be square root of x squared minus 4. And so I know that the inner function has no domain restrictions. However, I see that this final answer does have a radical. So the inside of the radical must be greater than or equal to 0. So I'm going to factor this. And I'm already thinking that on these problems where you have an inequality with a that's factored, you got to use test points here. So I'll go ahead and do that. These are closed dots, all right. Okay, so we'll try out like x equals negative 3. That would be negative negative, giving us a positive. X equals 0 would give us a negative and then a positive, so that's negative. And then x equals 3 would give us a positive and a positive, which would be positive. Now I want the positive, so I'm going to go out there and over there. So we get negative infinity to negative 2, 2 to infinity. All right, next up here, we are given an equation for the height of a ball. It's asked for the max height, and so that's just going to be the y value of the vertex. So I'm going to let you guys try to figure that one out. It does say it's a height, and so that's why I know it's the y value. If it asks at what time does it reach its height, then that would be the x value. All right, next up, number 19 here. So this one is a piecewise graph. It's multiple choice, though, so I would really just do this based on kind of my knowledge of each function. And so this one and the parent function would be a square root. And so that's looking like half a parabola. And the middle function here is going to be linear, so that's going to be a negative slope. And then the last one here is a upside down absolute value. So that usually looks like a V, but if it's just a piece of it, it might look like linear. Okay, so I think that A can be pretty easily taken away. You see that these are like constant functions down here. And then this one looks either like cubic or quadratic. I'm not sure, but it's definitely does not match up with this function. So all three of these bottom ones then do look like they all look the same, first of all. And so they have that that square root half a parabola on its side here on all three of those. Then they have a negative slope linear in the middle, and then they have, it looks like linear, but remember that could just be like half of our absolute value that's upside down. So those all check out. So then really what I need to check is the open versus closed circle. And so I know that this one should end at a closed circle at 0. So then I can say that B, because of this, is incorrect. But it might be C or D because they do have that closed circle you can see going left at 0. So then I would say at our next spot, the linear function here in the middle should have a closed dot at 4, whereas this one should have an open dot at 4. So then I'm going to say that that's got to be D, because I'm looking for the open dot going right and then the closed dot on the one in the middle. All right, next up, number 20. So for this one, I'm going to say that we have, once again, we have linear here. It's going to be a negative slope. And then this one is a constant. And so that should be a horizontal line. And so B doesn't have the constant graph. And D doesn't have the constant graph either. So it's between A and C. And once again, you would check the dots here. So this one should have the open circle going right. So I would say that's C. All right, next up, number 21, we want to do our difference quotient. So I'm going to find f of a plus h first. That's kind of the hardest part here. So it would be negative 2 times a plus h squared minus 5 times a plus h plus 3. And so then I get a squared plus 2ah plus h squared. And then if I distribute this, I'm going to get negative 2a squared minus 4ah minus 2h squared. And then I'm going to go ahead and add the rest of this. So minus 5a minus 5h plus 3. And then minus parentheses. And then I'm just going to plug in an a here. All right. Cool. And so that's going to be all over. Actually, let me get in blue here. That's going to be all over h. Okay. So now I'm going to distribute this negative, which is going to flip all these signs. I'm going to cancel a bunch of stuff out. 5a, negative 5a, negative 3, positive 3. So then what's left over is negative 4ah plus, no, not plus, minus 2h minus 5h all over h. And then we're going to take out the h. Oh, this was h squared right there. Okay, so then that will leave us with an h right there. We cancel that out. We get negative 4a minus 2h minus 5. All right, 22 here, domain. We have kind of two rules in play. So the radical must be greater than or equal to 0, and then the denominator cannot equal 0. So I'm going to factor this denominator. So it's x minus 6. Oh, no, it's not. Huh. I was going to do 6 and 8, but that doesn't make 16. So what else multiplies to make 48? All right, 4 and 12. Oh, yeah, that is it. So x minus 4, x minus 12. So x cannot equal 4, x cannot equal 12. So then I would draw this on the number line. You kind of don't have to, but it kind of helps to visualize that greater than 0 would be going that way, but we need to take a quick stop at 4 and a quick stop at 12. So that would be bracket 0 to 4, 4 to 12, 12 to infinity. All right, next up, given this function, they want us to do these two parts. So the first part here, f of x plus 7, means plug in x plus 7 for x. So that would be x squared plus, and then remember we're writing this twice. So that would be 7x and 7x, making 14x, and then 49. So then we get x squared plus 14x plus 59. Now this one over here, I would just write the original function once here, and then I would add the function with me plugging in a 7. And so that would be x squared plus 10 plus 49 plus 10, so x squared plus 69. All right, next up, number 24 gives us three functions and asks for f of g of h of x. So I would just kind of work my way inside out, and so I'm going to start off by replacing the h with what it is, so that would be rad x. So then I'm going to plug that rad x into the g function, so that's going to be rad x minus 9. And then I'm going to plug that into the f function. Actually, there's no more f because I'm plugging it in now, and so that would be rad x minus 9 squared plus 1. We could write the rad x squared minus 9 twice and FOIL it, but I would guess they left the answer like that. Let me check the answer. Yeah, they do. So I would just leave it like that. All right, next up, number 25. So this one, they said how many units should be manufactured to obtain the maximum revenue. And so for this, I would say we're just going for the X value of the vertex. We're still going for the vertex because it is a max value, but we're not actually finding the max revenue. It's how many units. So I'll let you guys do that one. All right, next one here gives us two functions, and this is actually a multiplying dot. So don't be confused between this one and a composite dot. The composite dot is like an open circle, but the multiplying dot is like a closed circle, I guess. So this just means multiply these two functions together. And so that's just going to require a FOIL. All right, next one here gives us a function, asks how long until it hits the ground. So this one is not asking for the vertex because it's not a max height. It's asking how long it takes to hit the ground, which is a height of 0. So I would do that. I would then GCF a negative, which we can always do if we are equal to 0. And then I would just factor this as t minus, let's see, that would be 8, and then t plus 7. So t could equal 8 or negative 7, but since it's time, I would only take the positive answer. All right, number 28 is just asking us to subtract the functions. The only thing I'm going to be cautioning you about is to subtract them in parentheses, especially the second one, so make sure you distribute that negative. 29 is asking us for the inverse, and so I'm going to switch x and y. And so then I would multiply both sides by y plus 8. And then, let's see, what would I do next? Is I would actually just not distribute that. I would just say y plus 8 times x equals 1. And so then I would actually divide that x back over, or not back over, but over. And then so I have y plus 8 equals 1 over x, and then I would subtract the 8 over. So f inverse of x equals 1 over x minus 8. Now, if it was free response, that's fine. You can leave it like that. But if it was multiple choice and that answer wasn't there, you could make a common denominator there. And so you could make this 1 over x minus 8x over x. So you could also say it's 1 minus 8x all over x. I'd say both of those answers are acceptable. So just multiple choice, find one of them. All right, next up, number 30. So on this one, it says a baseball team has a stadium that holds 55,000 spectators with ticket prices at $13. The average attendance has been 36,000. And then for every $1 the ticket price is lower, we're going to get 4,000 more people. Okay, so the revenue that we're going to get is going to be the number of people that show up times the ticket price. But I can change the number of people that show up by changing the ticket price. So this equation will be 36,000. And then, because that's our average attendance right now. And then it's saying that we can actually add 4,000 people if we lower the price of the ticket. So it depends on how much we lower it. And so what I'm going to put in here is I'm going to put 13 minus x. And so what this is our current price. And then what x is our kind of, the price. I'll call it the projected price, the price we want to change it to. And so what that's saying is if I change the current price to 12, then 13 minus 12 is 1, and I'll get 4,000 more people. Now you can also kind of do this the other way, where you say n equals 36,000, and you could say we'll lose 4,000 people, and then we have to switch this around, saying I'm going to raise the price. Okay, so now we're going to substitute that in for the n over here. Now this one actually does not ask for the vertex. It asks for no revenue being generated. So you're gonna, once you kind of do that, you're gonna set r equal to 0 and solve it. All right, once again here we have inverse, so we're gonna switch x and y. And so now I need to isolate x, so I'm gonna send it to the third power. And then so I get x to the third equals, oh shoot, this was supposed to be a y. Okay, so that'll be 4 minus y to the 7th. Now I'm going to subtract 4. X to the third minus 4 equals negative y to the 7th. I'm going to divide by negative 1. So I'm going to get y to the, negative x to the third plus 4 equals y to the 7th. And then we'll do a 7th root to get rid of that. So there's my answer.